Hey, it's Sukrit from STEM Coder, and today we're going to learn a new topic, implicit differentiation. So, how does differentiation work normally? We have our function y is equal to 3x squared, and normally we take the derivative with respect to x on both sides, right? Because if we have an equation, we've got to perform this operation on both sides. So, when you do that, we get dy over dx is equal to 6x. And a lot of times we write it as f of x instead of y. Well, y is just the output of f of x, so we can also write this like this, so f prime of x. So this is another way we can write it. But what if we have an equation like this, x squared plus y squared is equal to 1? Well, this is not a function. It fails the vertical line test. For one input, there are two possible outputs. But what if I want to find the slope of the tangent line at any one of these points, like the slope of the tangent line over here? How do I do it? Well, we have this thing called implicit differentiation, and let's go ahead and use it right now. So much like before, I'm going to perform the operation d over dx on both sides. So d over dx of x squared plus y squared is equal to the d over dx of 1. So I've just taken the derivative with respect to x of both sides of this equation. And we've broken this up into two parts. The derivative with respect to x of 1 is just 0 because this is a constant. So let's try evaluating this. What is the derivative with respect to x of x squared? Well, that's just 2x. It's actually one of the first things we learned. And now this over here may be a bit more complicated. It's not exactly straightforward, but we are taking the derivative of y squared with respect to x. What is the derivative of y squared with respect to x? We don't know, right? But thank goodness we have the chain rule. Now, the chain rule basically states that the derivative with respect to x of a composite function f of g of x is equal to dy over du times du over dx, where y is the output of f, u is the output of g and the input to f, and x is the input to g. That's also f prime of g of x times g prime of x. It's the chain rule which we learned in the last video. So how exactly can we apply the chain rule over here? Well, look at this. This can actually be written out as the derivative of y squared with respect to y times the derivative of y with respect to x. Now this is fine. Why is this? Because y, we can actually consider this squared over here to be a function of y. So y squared is a function of y, and y is also a function of x. So you input x, you output y. You input y, you get y squared as an output. So we can actually use the chain rule to split this up into the product of two derivatives over here. This is obviously equal to 0. Now see what's going on over here. Let's now evaluate this further. Now it's going to be 2x plus. Now what is the derivative of y squared with respect to y? Well, it's pretty much like the derivative of x squared with respect to x. It's just going to be 2y. So 2x plus 2y times dy dx. I'm just going to keep it as dy dx equals 0. Wait, look what we found. Dy dx. That's the derivative of y with respect to x. And that's what you need to find the slope of the tangent line. So let's rearrange the terms a bit. So 2y times dy dx is equal to negative 2x, and dy over dx is equal to negative x over y. And look at this. We have actually found the slope of the tangent line in terms of both x and y. Now, you may not have seen anything like this before with derivatives, but this is actually perfectly fine. And let's look at an example. Suppose I want to find the slope of the tangent line at this point over here. And by the way, this point in the circle, this is root 2 over 2 comma negative root 2 over 2. So root 2 over 2 comma negative root 2 over 2. Well, all you got to do is plug it into here. And over here, the slope of the tangent line is going to be negative x. So that's going to be root 2 over 2 divided by y. And that's going to be negative root 2 over 2. And this is actually just 1. The slope of this tangent line is 1. So look, with implicit differentiation, we can actually find the slope of the tangent line of an equation which is not a function. This isn't a function, but we have still used derivatives to find the slope of the tangent line. This time it's going to be in terms of x and y, not just in terms of x. And we will be using implicit differentiation in the future to prove other properties of derivatives, and we'll be using it a lot actually in our calculations. So make sure you understand it well. The chain rule over here may not seem intuitive at first, but just remember, y squared is a function of y, and y is a function of x. So we input x and we get y. We input y here and we get y squared. So this is actually a composite function over here. Y squared is a composite function, and we have simply used the chain rule to separate it out into two derivatives. We'll be using this trick a lot in the future. I hope you found this video helpful, and I look forward to seeing you in next lesson.